The ocean produces enormous amounts of energy. Harnessing this great power is an environmentally suitable alternative to using fossil fuels to generate electricity. Prospects of using wave energy for conversion into electricity has been around since the 1970s, but recently, since the 1990s, increased attention and interest in the technology has been pushed forward. Wave power potential is related to the movement of the winds and their distribution. The strongest winds occur between 40 degrees and 60 degrees in both hemispheres. The southern and western coast of Australia exist in these locations, and therefore has the greatest wave energy resource than any other coastline in the nation. Here wave energy is averaged at about 84 kilowatts per metre. Any site in the world with an average power level over 15 kilowatts per metre can generate power at competitive prices. Figure 1 shows the country and its relationship to the rest of the continents. Here, the orange areas illustrate the zones where the strongest waves are recorded. You can see that Australia, Hawaii, Northern Canada and Scotland are countries close to these zones, all of which have active vessels and research in wave power. Figure 2 illustrates a local map showing the south margin of Australia, where harnessing wave energy is most promising. This figure shows the average annual wave power levels as kilowatts per metre. Again, noticing Australia, Hawaii and Britain. In Australia, the strongest winds occur between 40 degrees and 60 degrees in both hemispheres. The southern and west coast of Australia exist in these locations and therefore has the greatest wave energy than any other coastline in the nation. The wave energy is averaged at 84 kilowatts per metre. Any site in the world with a wave energy power level from 15 kilowatts per metre can generate power from waves successfully. The Australian southwest coast between Perth and Hobart sees some of the most energetic waves than any other margin of land. The Australian southern margin has been identified by the World Energy Council as one of the world's most promising sites for wave energy generation. Australia has a large potential to create electricity from wave power and is therefore a large market. The pattern of seasonal variation is consistent with more energetic conditions in the winter and spring periods due to the passage of heavy temperate storms and less energetic in the summer-autumn periods due to local sea breezes. Australia is also consistent between switching from moderate energy conditions during the southeast trade winds between May and November and mid-monsoon conditions December to April. Australia is largely untapped resource and has the advantage of having the highest density of all renewable energy resources. The three main devices being used to harness wave energy are attenuators, point absorbers and surge converters. Attenuators, like this one, called the Polaris, flex and move with the action of the waves. Harnessing is kinetic energy. This is a point absorber that absorbs the wave energy in all directions as it bobs up and down. Here, this surge converter has a tethered arm which swings like a pendulum to wave surges. The United Kingdom is the leading country in wave technology research, and most of the wave energy developers there have been working in an area along the British Isles. The British government pledged $100 million to the wave development programs there. The UK was also the first nation in the world to set up its $5 million facility in Orkney, Scotland to test potential wave power generators. Ocean Power Delivery in Scotland has produced a device to convert wave power into electricity. The device is named after the company that invented it, called the Polaris. It is 100 meters long, 3.5 meters wide and weighs 700 tons. Out of all devices, this one was seen as the only one ready for deployment in the US, and in 2004 electricity was fed into the grid. The company has just recently announced a business partnership with the equipment contractor, the Portuguese firm Enesis. Over 20 countries in the world have ongoing wave energy projects, but while solar and geothermal will show a steady increase over the next 25 years, wave and ocean power generation will increase by over 100 billion kilowatts per year. The technology for wave power, unfortunately, is still mainly in pilot stages and proof of concept stages in other countries around the world. But once efficiency, awareness and education catches up, we are expected to see the trends as shown in the previous graphs. Not many people know that the density of the power created by the ocean waves is 5 times more dense than wind power. The ocean is an unexhaustible resource. It can be harnessed to produce 100% green energy. If a mere 10% of a 1,000 kilometre coastline was harnessed, Australia could reduce its fossil fuel emissions by 50%, setting a target the government made to be achieved by 2050.